Okay, so we have another identity to verify, and it uses a process that I don't know you would necessarily think of on your own. So we mentioned it, or I mentioned it, but I want to show it to you how it would work. Okay, so you look at this identity, and the first question you might have is, well, which side is more complicated? They kind of look like the same, right? So maybe I'll work on the left-hand side. You probably could do the same thing by working on the right-hand side, but I think it probably is easier to work on the left-hand side. And what I'm looking at is the denominator is a little more complicated on the left than it is on the right. So it would be easier for me to get my denominator to be one term. That's kind of my idea. Okay, so I'm going to take my cosine theta over 1 plus sine theta. And what I'm going to do is I'm going to multiply by the conjugate like we've done in the past, 1 minus sine theta. Now, the reason I'm doing that, of course, I have to multiply in the numerator as well as the denominator. The reason I'm doing that is because I want to get a sine squared in there. And this will keep me from getting a middle term, okay, when you multiply by the conjugate. You can think about that. We've used that process in the past in algebra. And you also notice that now I have that 1 minus sine theta in the numerator, which is what I want, right? Okay, so there's going to be a little more work, but let's see what happens here. The numerator I'm going to leave as cosine theta times 1 minus sine theta. Now you might say, well, why don't you go ahead and distribute the cosine theta? I don't want to do that because I'm hoping that cosine theta cancels, because you'll notice on the right, I don't have a cosine theta in the numerator. Okay. So over, and then what do we get when we multiply this out? Well, you could use FOIL or the idea that it's the difference of squares or however you're looking at it, but it's going to be 1 minus sine squared theta. Now, that should ring a bell, hopefully. So the idea is 1 minus sine squared theta is equal to cosine squared theta. Okay, so that comes from the Pythagorean theorem. It's one of those alternate forms. So then I can replace that. So cosine theta, 1 minus sine theta over cosine squared theta. Now, when you're doing these verifications, you need to show these steps, okay? I don't think I'm putting in any extra steps here. Like, I would need to see all this work, okay? We already know it's true. You can't just say, oh, I'm looking at it and it's true. You have to be able to show. You have to be able to communicate how you know it's true, okay? All right, so sometimes that's a sticky point for students. Okay, now I can cancel one of these cosine thetas with one of those that's cosine squared. So I still have a cosine theta left, but that's okay. Now I have 1 minus sine theta over cosine theta, and that's what I wanted. But I wanted to show you that process because I don't know that you would just think of that automatically. Oh, I'm going to multiply by the conjugate. So there you go.